This is part 2 of the Math 251 lecture for Monday, November the 30th, when my computer went down for a moment. So I will try to record the rest of it for you. So let me go back and try to share the screen. All right. So I think my computer went down right around here, around 15. Let me go back and double check 15 for you. So y equals integral from 1 to 3x plus 2 of t over 1 plus t cubed dt. So to find the derivative, put 3x plus 2 right there and right there. So it looks like 3x plus 2 over 1 plus 3x plus 2 cubed. And then by the chain rule, it's times the derivative of 3x plus 2, which is just 3. And you can just leave it like that. Okay? Don't try to take the derivative. Don't try to take an antiderivative. You are taking the derivative of this integral function, y. Okay, 17, just in case. Okay, so radical x pi over 4. This is backwards. So I take the negative of the flip. So I'll put pi over 4 on the bottom, square root of x on the top, and a negative in front. And now that's the way we like it. Namely, it's supposed to be constant on the bottom, variable expression on the top. All right, and keep in mind, square root of x means x to the 1/2. So negative is in front. Put the square root of x right there and right there. So radical x, tan radical x. And then by the chain rule, it's times the derivative of the square root of x. Keeping in mind, square root of x means x to the 1/2. Okay, so the derivative of x to the 1/2 is 1/2 x to the minus 1/2. And then clean that up. 2 goes in the bottom. Square root goes in the bottom. Looks like that square root of x can cancel that square root of x. So final answer is negative 1/2 tangent square root of x. Okay, that's problem 17. Okay, and then the problems at the end, again, problem 59, I'm sorry, 59, 5.3. So what happens if there's a variable expression here and here, 2x and 3x? So the way you do this is to split it into the integral from 2x to 0 and then 0 to 3x. And technically, you can put any number that you want. You can put 5, you can put 21, you can put your favorite number as you want. Any real number would work here. So 2x to 0 and then 0 to 3x. Okay, this one's good, constant, variable. This one's backwards, variable, constant. So we know what to do. Flip it, 0 to 2x, put a negative in front. Constant, variable, constant, variable. Okay, so for g prime of x, you're actually taking the derivative. Put the 2x right there and right there. And then times the derivative of 2x, which is 2. For this one, put the 3x right there and right there. And then times the derivative of 3x, which is 3. And then we just clean it up a little. So there's a negative 2. So 4x squared minus 1 over 4x squared plus 1. And this becomes 3 times 9x squared minus 1, 9x squared plus 1. And there we go. Okay, and here's 63, the last one. So same issue, variable expression, cosine, sine. So break it up into cosine x to 0 plus integral from 0 to sine x. Okay, constant, variable, this one's good. This one's backwards, variable, constant. So we flip it, put the negative in front, put the 0 on the bottom, cosine x on top. And now both of them have constant on the bottom, variable expression on the top. Okay, so cosine x goes right there. So ln 1 plus 2 cosine x. And then by the chain rule times the derivative of cosine x, which is negative sine x. And there's a negative and a negative there, so that becomes positive. And then how about this one? Put the sine x right there, 2 sine x, times the derivative of sine x, which is cosine x. So there we go. So we have ln 1 plus 2 cosine x times sine x. I had double negative there. Okay. And then plus ln 1 plus 2 sine x times cosine x. Right, so there we go. So this was fundamental theorem of calculus part 1. All right, so that hopefully is the rest of the problems that we did for today's lecture, Math 251, Monday, November the 30th.